All right, well, here goes nothing. Our question is, the question before us is, can I draw a line that passes through no lattice points at all? Can I draw a line that passes through exactly one lattice point, no more, no less? And can I draw a line that passes through exactly two lattice points, no more, no less? Remember, a lattice point are these points where the grid lines cross. Okay? Or another way of thinking of them, they are points on the grid with whole number coordinates. So 1, 1, 2, 1, 3, 2, and so on. No fractions or decimals or anything. Whole number coordinates. And by the way, the answer is yes, yes, and no. Which seems a little unlikely if you think about it. So you're telling me I can draw a line through the grid, right? And the line goes on forever in both directions, and somehow it's going to magically miss every single lattice point. But like, if you look at the grid, if the grid were to continue forever, go on forever in all directions, that's a lot of lattice points. You're telling me I could like somehow shoot through this grid and miss every single one forever. That just really seems unlikely. Seems also unlikely that I could hit just one and then somehow miss all the others, right? So I'm going to give you an example of a line that hits just one and misses all the others. And you can use that to kind of figure out how it is that you could miss all of them. Or I want you to take a look at here why it is that if you hit two, then you can't hit just two. Okay? Anyways, let's look at this one first. The example is going to be y equals x times square root of 2. All right, so this is a line with a slope of square root of 2. Now, square root of 2 is an irrational number. Okay, 1 second. Okay, now square root of 2 is an irrational number, which we normally think of as it's a decimal. It's like 1.41 dot dot dot. We think of it as a decimal that goes on forever and doesn't repeat. But that's just like a characteristic of it. It's not really what makes it an irrational number. What it really is that square root of 2, or I could write that as square root of 2 over 1, is never equal to a over b, where a and b are integers, meaning that I can't write it as a fraction. Right? I cannot write it as a fraction with two whole number parts. Okay? Now, if we think of this as a slope we could write as a fraction, a over b, rise over run. But if we notice, think about this, if b is, say, 2 units, then a, if the run is 2 units, then the rise part can't be a whole number because square root of 2 cannot be written as whole number over whole number. Okay? If the run is 3, then the rise part cannot be a whole number, right? Because square root of 2 cannot be written as whole number over whole number, right? So if I can start plotting these points, right? Well, 0, 0 is on the line because 0 times square root of 2 is 0. And that is, by the way, our one lattice point that we're going to hit. But then beyond that, let's say it was over 1, it's going to be around 1.4. See, if it was 2, it'd be 2.8. If it was 3, it'd be 3 point some up here. So our line kind of goes up like this, right? But for every x that I might plug in to this equation, or for every just a second. Okay, maybe I shouldn't write this. I'll write these as A1, A2, A3, A4. Okay, so no matter what denominator I put down here, no matter what our run is, the rise, as long as the run is a whole number, the rise can't also be a whole number because that's the definition of an irrational number. An irrational number cannot be written as a fraction where the numerator and denominator are both whole numbers. That's the definition of what an irrational number is. So for whatever I go over, my run, the rise is going to be some decimal that goes on forever and doesn't repeat. It's not going to be a whole number. So, which means that at no point, and not at x equals 1, x equals 2, x equals 3, x equals 4, x equals any number at all going on forever or going in the opposite direction, negative x's, will I ever get a y that's a whole number, because the rise part, right, in my slope calculation will not be a whole number. It can't ever. Okay? So somehow magically, almost it seems, this line is going to narrowly miss every single lattice point in its path, going in both directions. Okay? Going in both directions. And that's what an irrational number is the definition of an irrational number. So now, of course, it does hit this one right here. It hits 0, 0. But you can probably alter this equation a little bit so that it doesn't hit 0, 0. And then it would hit no lattice points at all. As for hitting 2 lattice points, just run some experiments. Draw a line that passes through 2 lattice points exactly, and see if you can somehow make it miss every other lattice point. You won't be able to. Okay? So try and figure out why that's the case, so you can come in with an explanation of that.